Hi, I'm Craig Rowland, founder of Sandfly Security. Today I'm going to demonstrate Sandfly's agentless drift detection feature, which is a very powerful way to determine any changes that have happened on Linux systems that you control. This isn't just modern systems. Sandfly is an agentless product, which means you do not leave a permanently running endpoint agent on any of your devices. That means we can run on systems up to a decade old, to modern cloud deployments, even very difficult to monitor embedded devices and Linux appliances. Sandfly could get onto them to provide immediate security monitoring. Sandfly's new drift detection feature, though, is a lot different from what many people are used to using. Many people might know about what file integrity monitoring is. Sandfly goes well beyond file integrity monitoring because we cannot just find files that have been changed, but we can actually find any new processes that have started, any new users that have been added, any new kernel modules that have been loaded, any new persistence mechanisms such as cron or at scheduled tasks, even systemd timers that have been dropped on the system unexpectedly. Sandfly watches a large variety of attributes on Linux to tell you if anything has shifted. For today's demonstration, to keep it short and sweet, we have profiled a box here at NYC01. This system here was our gold image that we wanted to use for our virtual machines. So we went ahead and we profiled that box, and I spun up 9 additional systems, so I have 10 systems total that should all be identical. With Sandfly's drift detection, we could put this into a scheduled scan so that we periodically check these systems to see if anything has changed. But it could also be used for immediate incident response. For today's demonstration, we went ahead and we scanned all the systems, built that profile on it, and then we rechecked the systems again to see if anything was different from our known gold image host. Down here, we see suddenly that this NYC109 system here has registered 6 alerts. When we click on these alerts, we can see these recon modules have indicated that something has gone wrong. The recon modules collect information from the remote system, and basically they just tell us what's there. And then Sandfly figures out whether or not that change is authorized or not. In the case here, we'll start at the top. We went ahead and we saw that there was a new user that logged in called root. Typically, this is not something you want to see. Some people leave root enabled, but in this case here, we know that as part of our default image, the root user was never logging onto that system. So this is immediately going to gain a red flag that we're going to want to investigate. We can even see additional information such as the host name. In this case here, this is a VPN that someone used to log onto the host, so there's no use going to that. But also we can go down here and we can see another login that happened in the last 4 hours, again from our root user. So we kind of get in a bracket of time of when this actually happened. The next thing we're going to look for here is our processes that are running. Someone got on this box and they started a new process up. Process detection is very, very important on Linux. And what's interesting about this is that Linux has a lot of ways for living off the land binaries to run in a malicious way. So for instance, netcat ships on a lot of systems. Netcat is an instant backdoor if someone wants to fire it up. So just because a binary is present on a Linux system doesn't mean it should be running, right? That's the difference here. In the case of Sandfly, we can see that a binary started that was not part of our profile, whether or not it's part of that distribution or not, and we will flag it. We can also find fileless malware that never even touches the disk. This is something that file integrity monitoring will completely miss, as well as many additional types of URL scanning. If we see a new process running that wasn't part of that profile, we're going to flag it. In this system here, we have the process name, information, hashes of it, and so on. Clicking on the process name, we immediately see something interesting here, that it's only ever been seen on one host. This tells us very immediately that there's something wrong here, because a process, if we saw it on more than one host, we could say, well, maybe that was something that's legitimate. But the fact that it's only on one host, this tells us that that is unique. And when you see unique processes running on a Linux system that should all be identical, that means there's likely a compromise that's happened. The next thing we look through here is a process persistence cron. We see that someone has dropped a new cron entry here. And again, we pull it out for you immediately. It's got this bogus domain in it, but you get the point here that this cron entry sticks out like a sore thumb. We know that this thing does not belong here, and we tell you immediately what it is. There's no need to go on a wild goose chase about it. You can see immediately that there's something wrong. And finally, last thing here, and I'll hit on this quick, is that we have our user here. We have a new user called system that was dropped in the box. We have all the forensic information about that user. Again, this username called system. Again, it's only present on one host, which is highly suspicious. We can see here too that they even have some authorized keys dropped on the system. And we even flagged that with this additional Sandfly check down here. Recon user authorized keys. We said the user system. Someone has added an authorized key file, or they added a new key to an existing authorized key file, likely as a backdoor. At this point now, we know pretty certain that there's something wrong with this system. Now, these are not threat detection modules. These are just drift. But just with the drift detection modules alone, we saw a user login that shouldn't have. We saw a suspicious process start. We saw a cron entry added to the system. We saw a new user added and a new user added that had a SSH key that was never seen before. This gives you an immediate indication that this system has something very, very badly wrong with it. And we did it all with our agentless platform, meaning that we did not leave anything permanently running on the endpoint. We show up, we do our work, and we get off. That makes us highly compatible. We never cause any system stability or safety concerns. We work on systems that are decade old, all the way through modern cloud systems. And again, we can monitor those critical embedded devices and Linux appliances that don't have any type of security monitoring in place. And they are an extremely good candidate for drift detection because they shouldn't be changing a lot. So anyway, that's an overview of Sandfly's new agentless drift detection feature. Go ahead and go to our website. We have a free license. You can use it on your home network and instantly find out today how powerful this new feature is. It's very, very difficult for an intruder to get onto a system that's being watched by Sandfly's new drift detection feature. Once you layer on our threat detection modules at all, it's very, very hard for an intruder to remain on these systems undetected. So I'm Craig Rowland from Sandfly Security. Thanks again for watching my video. Have a good day. I appreciate your time.